All right, so now that we've did a little bit of writing files, so we have functions like read and write that will work on files. So, but the first one we need is open. So there's different ways of calling open. You can call it with one of these modes. With all these Boolean arguments to set a mode, you can call it with one of these strings to set the mode. Or you can do this. So this is a way of, let's see, this takes a function so that you don't have to remember to close your file. So in this case, we could, so f equals open, our file is called normal, and we want to open it for reading. And so that's, the IO stream is how Julia is representing what we've just done. So when you open a file, it's a stream. The same thing happens when you have a networking connection open, or when you're getting input from another process. All of those are IO streams. So in this case, let's try read all of f. And so this read in the whole file as a string. Another way that we can do it, if we start over with that file, is for line in f. Streams are iterable, wait, I'm not sure whether this is going to work. I might need to actually read the lines in separately. Yeah, okay. So streams are not iterable because what are you going to iterate over? How does it know that you want to iterate over lines instead of bytes or something? So instead, I can make lines equal to read lines of f. And so now I have all of these strings, and I can for loop over that. So let's see. So read lines is what we just used. Read line is what will read you one line at a time rather than reading the whole file in at once. Okay. So that's how, those are ways of reading in data from files. We can also write data to a file, so f equals open, let's open space for writing. Let's see, so methods with type of f. So there's lots of things we can do with this. So for one, we can double check that it's open. Ooh, that's exciting. I would like to save that for later. Yeah, I think it's a problem with my computer, but I should look into it later. Where did I put our console? Okay, so there's where we have one in Julia. That was the first one in Julia. Okay. I'm sorry for losing that terminal. Okay, that's not the right one. Okay. I'll mess with that later. Okay, so, all right. So that function would give you a Boolean to tell you whether the file is open. So I'm going to use, so we could write to it. So let's see, help write. So we could write hello to f, or write to f, right, hello. So now if we go back to, not this one, but this one, we can cat space. That's not, I'm going to try naming that file something else. Oh, maybe I should close F first. Okay, so I have to close the file before it will finish writing to it. All right. So if I open space again, I can write world peace. Okay. And then I'll close F again, and then now we can see the contents of the file. Okay, so we've read and written files. We can look at the files in our directory. Okay, so now I'm going to talk a little bit about TCP sockets, and I'm going to show you an example of using them. So if you want to open, let's see. So there's TCP servers and TCP sockets. So one of the other things I can do with, let's see, so if I want to listen on a particular port, so I can call, let's see, so my server is going to be listen on port 8080. And so now I have a TCP server. And so now I need to accept, so my connection is I'm going to accept a connection on server. And so now I was going to sit here and wait because nobody's connecting to port 8080. I guess I should go do that. So I'm going to use netcat to connect to localhost 8080. And so now this returned, because I went, oh, I got a connection. We can stop waiting. This means that if you do a for loop or a while loop while the port is open, keep connecting, you'll get an infinite loop because it'll just stop every time to wait. And it also means that you'll only handle one request at a time because you have to get back to that accept to accept the next connection. Okay, so we've accepted a connection. So my connection is a TCP socket. I can write to it. So I can write to connection, hello. And now you saw over here, I got a hello in netcat. Oh. Okay. So that has a hello. Let me see if I can. Okay, so we got a hello there. If I read line connection, I get my new line because I pressed enter once in the console. If I read line again, so this stopped. If I were in a file, it wouldn't pause like this because it can get to the end of the file. Here it goes, well, I don't know where the end is. I haven't found a new line, but I also haven't found the end of the stream because it's still open. So I can type and so I got that whole string in the Julia console. So one thing I could do is, so I could get a string this way, so maybe like rocket. So s equals readline connection. And now if there's a function for removing, let's see, so if I strip s, okay. So f equals strip of s, I want to get rid of that new line, the white space, and now I can results equals read all of grep s read here. So the example I'm going to show you is, first we can run grep locally and return the results over the network, just using the simple TCP socket interface. And so the only thing we have left to do here is to write the results to the connection. And they appear just like that. So that's one thing, so that's a quick thing we're going to do, I'm just going to type it into this into a file so that we can actually like see what happens when you put it in a file, and then after that I'll show you a pure Julia implementation that does the same thing as this this particular part of grep's features. I'm sure grep has plenty more features, but this is just going to be a simplified version. So N for like networked grep. So Julia files end in .jl. Most packages also end in .jl. Like if you look on GitHub, most of the package names will be package name.jl. This helps us differentiate from other languages that have libraries with similar names. So if we do email.jl, you'll be able to tell that it's not like the Python email module or something. This is specific to Julia. So if I make a function grep that takes a query and it's going to return my results. So this will just do read all grep. Oh, sorry. All right, so grep query read dir. And so that's exactly what we just ran in the REPL. And so that's our function that's just going to call grep. And so by modularizing this way, I can just re-implement grep later in Julia, and it will be transparent to the rest of our code. Function, let's see. So the rest of this file, we can run it as, what am I going to do? So I need to start a server. So server equals listen on 8080. And then our connection equals accept on the server. And then read line on connect. So Q for query. And then write to the connection the result of running grep on the queue. And so this is what this is going to do is it's only going to accept one query because we have no loop here. So, and this time, so I'm going to kill this, and then, okay, so let me get this over to the left, so you'll be able to see it too. Okay, so there's that one, and here's netcat. Okay, so first I'm going to, so when you want to run a file, you can use, you just run the same Julia executable that you use to run the REPL. I haven't aliased it to Julia, I should do that. So this is just the same thing I ran to run the REPL, and then I'm going to give it a file as a command line argument, and this is going to make it run ngrep as a script. It's going to need a minute to start up because the same way the Julia REPL takes a little bit to start up. Interesting. Right. I should not use the same thing. Okay, so close connection, close server maybe? Okay, let's see if this works. So this is going to take a moment to get there because like the same way like the REPL takes a little bit to start up, we have to start up the whole same stuff as the whole JIT compiler and everything. And like parse all of the libraries. So the Julia REPL has to, while all of the base libraries in Julia itself are pre-parsed, like we store them in like a pre-parsed state, it still has to, boot itself up and like JIT compile some stuff before it can start running. So right now it should be ready. So now I'm connected. So I'm going to be able to type in a query and get the results for just one query. So if I type in rocket, so it also gave me results from grep, which is interesting. So let's see. We got rocket, which I typed in, and then in space we got some results. That's interesting. So we got everything in the space file because it contained rocket. That's interesting. I wasn't expecting that. This seems like surprising output. let me look at that file again. So I'm trying to find, all right. Well, so that's the same code. If I do run grep rockets read here. If I do aha, okay. So the problem here is that we did not remove the new line from the end when calling grep. I'm also going to add a print line here for the server to let us know that we're ready to accept a connection. Okay, so now I'm running the file again. The problem before was that I had a new line at the end because I hadn't stripped off the new line that that gets read out of the socket because we have to use a new line in order to send the query. Okay, so we connect again and give it rocket again, and it gives it back rocket ship, which was the expected result. Now note that, yeah, so netcat takes a minute to realize that the pipe is broken. I think if we actually close the connection, it probably will, I expect that it will close the netcat session immediately because the thing is closed. Let's see. So let's try hi. So we get our results, and let's see. So you're not done. There are you. Interesting. I was expecting both of these programs to end now. Interesting. All right. So anyway, the next thing I'm going to do, now that we've done, so we've done some stuff with basically just shelling out to grep. So the next thing I'm going to do is writing a Julia version of it that involves regexes and opening files and hopefully closing them again, and which will be a pure Julia version. Don't know why that isn't ending. Anyway, so if we comment this out, so in Julia, the only kind of comments are pound sides. So the only, we don't have I don't know, /* or anything, it's just pound signs. So if I make function grep query, so if we're going to implement grep here, we want to open each file, find any lines that match the query, and then close the file and print out, pass back a string that has all of those lines concatenated, right? That's what we've got in our results so far. So for file name in readdir, and now we don't need all of those parens and $signs since we're just calling the function. Okay, so I'll need, let's see, so I need a results string, and it starts out empty, and then for line, so let's see. There's probably a function for finding the end of a file. Let's see, is empty. I don't think that is done of F? No. Oh, EOF of F. Okay, so EOF is a function to tell us whether we've reached the end of a file. So while not EOF of, oh, I should open the file first. So file equals open. We're going to open file name, and we're going to open it for reading. So while we haven't gotten to the end of file, our current line equals read line of file. So now we have a variable line. So now we want to check whether it matches the query. So there's a function called isMatch. And so this is going to take a regex and a string. Regex is a type. Regex will take a string. Notice how it prints out. This is special. So the R on the front is to indicate that this is special string syntax. So you can define new types of strings that get parsed a bit differently by defining their functions to parse them. So R of rocket is exactly the same thing. So like I can add some like special regex stuff and it'll show up in there. So this is just like the type of that. So the type of answer is of type regex rather than of type string. So this got parsed differently. And notice that the $sign and stuff were fine. Yes.
Equivalent to the raw string in Python.
So the question was whether this is equivalent to a raw string in Python. I think that what the parse function gets for regexes will be very similar, but the result here is different. Like it parses it itself, so the object you get back isn't a string anymore. All right, so first let's make our regex up here. So right, R for regex is a regex of query, which should be a string. And so if isMatch, so isMatch takes a regex first, R and line. So we tend to append to results. So I can use, so we have like star equals and plus equals and all of those. And since times is the operator for appending to strings, I can do results times equals, let's see, we're going to do file name, and then a colon, and then the line, and then a new line. And so that should make lines that look like this rocket ship line. Well, line should have a new line at the end, so that should be okay. Also, we should strip the white space off of the query. So we've checked if the line matches, we've added if it does. So now we need to close the file so we don't use up all of our file descriptors. And so we've done that for all of the file names. So then at this point, we can return results. And we don't have to use the return keyword because this is just going to be the last expression in the function, so results will be the return value. Now I don't have to change the rest of the code because this grep behaves in the same way that our previous grep function did. All right, so let's try running it. So it's ready to accept the connection. So we'll connect to it. And then let's try rocket again. Cool. So We can also try some other things. I should have put a little bit more. So we can try high. And so we got, interesting. So rocket ship show up because it has high here. We got another line that has high. Ngrep has high in the while. Can also try, let's see. So if we, so we have like Hello World in some of them, Snowman. All right, I should search for my Unicode Snowman. So I connect via Netcat again, and now my query is Snowman. And now I have lots of snowmen. And so this worked just fine when we were reading from the TCP socket, and Julia just took all of the snowmen in stride. So because we have UTF-8 strings, and you don't have to do anything special. All right, so I covered how to like write grep in Julia, regexes, some file stuff, some shelling out. A little bit of networking. Does anyone have any questions on anything I've covered so far? Yes. Yes. So the question is about pretty printing functions for pretty printing arrays and matrices. So there's the the default stuff, like the way it prints in the REPL, which is already like designed for the REPL. So for example, when I do, let's see, I think if I do, so this is a very large array. So this is the way a 100 by 10 by 5 array prints out at the REPL. So we get some dots because it's only showing me the 4 corners of the array. And so this is showing me, so I have a 3-dimensional array, so it's showing me the 5 slices, you could say, of the array. So it's showing you the whole, these colons are saying, well, it's all of the indices for the first 2 parts, and then specifically 5 for the third thing, which is kind of a lot of output. Let's see what it does if I say 500. So it's showing me the last 3 and the first 3. So it abbreviates each of them, and maybe it should abbreviate more, I don't know. But so this is what large arrays look like when they're printed at the REPL. There's also some other functions, I believe summary. So summary of, let's see, so I don't want to summarize help, so I want this one, and so summary of that is much shorter. So what kind of, was there a different kind of pretty printing you were looking for?
Well, specifically I was wondering, like, when you have that list of all the available packages, it's
Yeah.
for a bunch of them, is there a more or less function?
So like to try to get more out of package.available. So this is a list of strings and it gets abbreviated. Usually the way that I do this is just to say for x in that print line x. So that will print out just everything for you. I don't know, there might be a function for doing that. I don't know what it is because like that's really easy. Obviously maybe having a collimated version like you get with ls or whatever with a tab completion would be better. But I don't know a function that does that. Okay, so we have like 15 minutes left. That was all I was planning to show. So any questions you have, I'm happy to answer.
So on the Julia website, it mentions running things in parallel across distributed machines.
Yes.
I'm interested in that.
So, okay. Yeah, I can show you some of the functions for that. So the basic function is for like starting to have more processes is add procs. And so this has some stuff there, but there are basically two ways to call it. One of them is add procs with an integer, and that will add that many more Julia processes on your local machine. That's great for testing when you like can't do stuff on other machines. The other one is you give it host names. So in curly braces, which will give you an any array, you put in strings for the host names. Usually the way you have that set up is you have SSH keys so that your main Julia machine can SSH without a password into the other machines. And so you just call that, and then it will just start up Julia processes on the other machines. All of the machines involved in this have to have Julia installed at the same directory, or like, I guess you can set that with Julia Home now. I haven't used this in like a couple months, so they've added more features, but originally you had to like have Julia installed at the same point in the file system on all of the machines. And then it would just start up Julia processes, and you can interact with the foreign Julia, like the Julia processes on remotely, the same way you can locally. So if I add some processes, so add procs of 2. So now it's going to take a minute because it's starting up Julia in some parallel processes and getting all of that done. And so, let's see, so what could I do? So let's see, so I can do processes, and this is telling me the 3 processes numbered that I have. So I can do spawn, let's see, so spawn at 1 or 2. So specifically from worker 2, so I told worker 2, so the second Julia process, I want to run this expression. And so worker 2 said hello because that's what I said, that's what I said. You can also use just at spawn and it will pick a random worker. Usually I believe they do some sort of round robin scheduling. But that way you get one of the other workers. You can also do everywhere. And so now all of those, so at everywhere, so locally we said hello, and then both of the other processes also ran the same command. I actually found that when I got to work on one of the clusters at school, and one of the neat things was that once I had Julia set up, it was easier to run shell commands using Julia and at everywhere than to do some sort of fancy shell thing to try to run the same command everywhere, because the Julia thing like worked consistently. This does mean, so like when Julia processes are on remote machines, they're using the local file system, or like as of last time I tried this, they would do the local file system on that machine as opposed to like, which will work fine if you have like a cluster with a global file system, which isn't that unusual, but it can be sort of strange if you're like working on 2 machines and you're surprised when like LS works weird. They're like creating files on the other machine means you have to go there to get your results. So one of the cool things, you have like D arrays. So a D array looks like a normal array. So if I make R be, just a matrix, I can then distribute R, let's make that R. And so this is going to take a minute because it's like taking the pieces and sending them to the other processes. So local part of D-array, we don't happen to have a piece apparently. But if I do that at everywhere, oops. Oh, because I didn't define this first. So like one of the problems you can get into is like if you don't define some things before you, like the shared state before you start, some of the stuff can get confused. So it's the name is confused because it's not, like the name isn't defined. I think that I have to, so I have array now, and then if, really, Yeah, there's sometimes you run into some of the like tricky parts are like figuring out. Let's see. Still seem to think that they're working. So fetch. Okay, I'm not really sure what that error message was. It might be something weird with the way at everywhere works. Yeah, I'm not really sure what happened there. But both of these seem to work fine for if you use spawn or spawn at. And so this is showing you that it decided to take one of the columns and send them to 3, and the first column is on 2. So local part is one of the neat functions that cares about where you're locally running it. So it's only showing you the part that is actually on that process, whereas I type in dr anywhere on any of the processes, it should show me the whole array. So the sort of neat part about a darray is that while there's a local part on each machine, so if you want to work with it, you should work with your local part, and you can get the indices for that as well. Like it'll give you ranges of indices and stuff. So you can do local work that's like easily on the like part of the worker that has its piece. But you can also see any parts, so you don't have to worry about wrapping carefully, because you can go, well, I can still see these parts that I access occasionally. Or like if you want to print them out on the main machine, you can also just fetch all of the pieces back together. There's also remote refs, which is so fetch. If you have like a result somewhere else and you've set up a remote ref, which is like a box that can be filled and can be emptied too. So you can wait for the box to be filled up by the worker process, and then you can fetch the results. I haven't used that API, so I'm not like familiar with it to like live code for you, but I'm sure that there's a section of the manual that covers that. And usually the manual, basically all of the manual is very well written. So you should be able to like figure most of that out by looking at the manual. You should also, if you have any more, like if you have any other, like you get stuck, you should always email the Julia users mailing list, which is it's a Google group. It's very active and very friendly, and they're always like happy to help new users. And like if you get stuck or have any like things that seem like they might be bugs, but you're not really sure and don't want to like commit to making an issue, you can bring it up on the mailing list first.
So our packages, does the package author have to know about distributed operation? Or does Julia have a way to distribute things that were distributed unequally?
So if you're calling a package, it would have to be like if it's not using these functions, it's not going to like use darrays or something. And like so some code won't work if you're giving it darrays. Like even though I think darray is probably a subtype of array, you can't write to darrays. So darray is still an abstract array. So a lot of the base functions will work, and a lot of like generically written code would still work with darrays, but not all of it would, because if they try to write to the array or like edit the values, it's not going to work because darrays don't let you edit them. Mostly because that would give you a bunch of problems with distributed stuff, like how do I keep all the copies in sync? So instead you just can't set values, but you can read from the same array. So like if you can call code, if the types work out, it's fine. If you're using multiple processes, you can still run Julia code on all of them. But you can't just like there's not some magic macro to say like distribute this library and somehow like make all the matrix contributions automatically distributed. You can't do that, but you can still like call the same code. No more questions? Thank you for listening.